Can you hear me now?
I can hear you remotely. So there are a few people just checking in, and I was going to talk for a few minutes on the mic, just to coordinate with my co-chairs, but also to make sure there's some audio feed into the remote room.
Yeah, we can hear you clearly, and all seems to be working.
Okay,
And
Mira, we have a couple of suggestions for the agenda, which we're going to announce anyway, so we can just tell you now and see if you're okay. The first one is I've arranged to swap two of the items on our agenda, and I've also done it in the agenda online, just to try and bring two topics together. So that shouldn't really be a surprise to anyone. That's the two individual drafts at the end of the session. Okay. You see that, Mira?
Okay, ready to start?
Yeah.
Yeah, Gori, that seems fine. I think we have. Oh, we will find the updated agenda, so we're fine here.
Yeah. Okay. Yeah, you will. Okay, and we may ask for feedback in Greg's presentation on the proposal from Mike Veltzel on the list, but I'll get to that when we get to the slide deck. So that's us coordinated, I think.
Let's get started.
Okay, good morning, everyone. This is the TSV working group. So we are at the first meeting here. We have another meeting on Thursday afternoon. Gori is remote, and since this is the first time for me chairing a working group meeting, Mirja agreed to help us here. So thanks for that. Next up, the Notewell. You've probably seen this already. If not, please familiarize yourself with this. Contains rules and procedures how we engage with the IETF and the procedures for intellectual property. We already found two note takers. Thanks a lot to Reese and to Anna. So that's taken care of. A general note, we need reviewers for our working group drafts. And for authors, please add the -TSV working group to any draft that you submit. So the title should be draft-IETF-TSV working group and then the name of what your draft does. To participate in this meeting, please use the Meet Echo mic queue. Just queuing at the microphone here is not enough. You need to be in the queue and appear on the screen. And then when it's your time to speak, chairs will call you, and then you can use the mic button to unmute yourself. As I said before, we need reviewers for our documents. That we can only ensure the high quality of our documents if we get the reviews. So if you have a document that you would like others to review, please put in the effort and review documents of other people. And with that, I'll hand over to Gori for the updates.
Okay, since we last met, David Black has stepped back as a chair, and it's now Martin and I in the chair position. But we have accomplished many things with David's help, and the big announcement, of course, is the L4S drafts were published as RFCs since IETF 115. check these out if you haven't yet seen them. They will appear talked about on the TSVWG agenda. We have one draft with RFC editor, which is the DSCP considerations. And we currently have no drafts after IETF last call for reasons we'll see on the next slide. Next slide, please. So we have two drafts with working group chairs because the last call didn't result in a document submission request. These two drafts are the ECN encapsulation for lower layers and the ECN for tunnels that use shim headers. These two drafts have been in this state for quite a while and are now progressing out of that state. Follow the discussions on the list. If you have any further suggestions, please supply them, but we're trying to resolve the text now, and Bob's hoping to produce new versions of these, which will be passable upwards using a Shepherd report in the near future. David Blackmark has something to say. David?
Yes, so the shim headers draft is actually good to go. The issue on that was closed quite some time ago. Bob's going to take one more shot at trying to write text that will survive for the minor open issue on the ECN encapsulation draft. We are cautiously optimistic that this will get through and we'll have this out of the working group the next time you see slides like these.
Thank you, David. And David's continuing to shepherd these documents, so please involve him in any discussions. So we have three other drafts which have moved through a working group last call. The first working group last call, we have the UDP options, DPLP MTUD for UDP options, which will progress at the same rate as UDP options, and the non-queue building PHB. So these three drafts are returned to the working group where we expect there to be some discussion. For the first two, we'll have an update later in this session, and we'll be working with Joe to produce new versions in the near future. On the NQB draft, we'll open an issue tracker, and again, we'll have a presentation later in this session. We expect another working group last call for both these drafts, hopefully in the near future. Next slide, please. So there are a number of remaining working group IDs. See the tracker page. The L4S Ops guidance was on hold by the working group and will be making itself into a submittable document in the near future. DTLS over SCTP is going to be talked about quite a lot in the Thursday session. Multipath DCCP is a document which is mature, and we'll have a presentation on that. And the user ports for experiments, we don't have a presentation this IETF. Please review it because it's near having a working group last call, and we expect to do that in the near future once we've coordinated other calls. Next slide, please. These drafts are not working group work items, but they are on this agenda list because they're related to this working group. We expect to see more about these first three documents at a future meeting, and we happily discuss these on the list with people, so please send comments to the list. The last item is up for announcement because it's progressed in TCPM and completed a working group last call and heading probably towards a publication request in the near future. This document updates the base spec for ECN by changing the TCP behavior. Mira, do you want to say something about the timeline for completing that document?
Yeah, we have, no, this is on. Yeah, we have one more revision to go, but I hope we can start the working group last call very, very soon. But I'm not the chair, so I can't tell you.
No, that's fine. I thought you were in the editorial team for that one, so yeah. And the reason for having this chat here is simply to keep you aware of the work going on. because it touched a TSVWG document. We don't expect much from this working group on this, but if you do have comments, please make sure that you put them into the TCPM list to make sure that document completes. Next slide, please. Milestones. The two new chairs, Martin and I, have been looking at milestones. We've reviewed milestones. These should actually be realistic, and my intention is that we keep them realistic for the group so you can see when documents are likely to be emerging from the group. The top one has not been revised for reasons we'll hear later in this meeting. So check the milestones. If you have questions on milestones, please contact the chairs and we'll try and update. Next slide. Which brings us to the agenda. Is it my job to talk about the agenda, or would someone else like to talk about it? My job, okay, excellent. Well, here is the TSVWG agenda. We have 2 meetings at this IETF. The first session is today, Tuesday, the second on Thursday. We've already been through items 1 and 2. We are now going to look at item 3, which is the differentiated services and AQM drafts, for which we have 2 things on the agenda today. We also have transport drafts to be discussed, looking at MPD CCP, UDP options, the 2 drafts, and next slide. A number of other individual drafts, including one from Nicholas Kuhn on careful resumption of congestion control, one from Matt Mathis on safe congestion control, and 2 drafts relating to signaling part of the work that we do in TSVWG, where we tell the network about quality of service or congestion control and other aspects of the transport, and hope that elements in the network responds to those requests. And these 2 drafts seem to be related in 5.2 and 5.3, or 5.2 and 6.1. So we did an agenda swap late in the process to put the 2 related drafts together. The final one being on encrypted transport protocol with path explicit signals. Does anybody have any comments about Tuesday's agenda? That's today's. Don't see anyone rushing to the mic. In that case, I'll carry on talking about Thursday's agenda. Thursday's agenda is about SCTP again. We have a longish talk by Magnus on DTLS protection for SCTP. The reason for that will become apparent as we talk about it, but it's been given a bit more agenda time than normal. And then we have various talks by Michael on SCTP related topics. We're hoping that this will conclude in time for a talk on enhanced port forwarding functions with CGNAT, which is item 9.1 on Thursday. So we'll try and manage the time to make sure that slot gets airing at this IETF. Does anybody have a topic for Thursday agenda or something which they think is missing from the 2 agendas? Which is great because it puts us on time for completing the chair slides. Next slide.
Wait, there's no next slide.
This is the last
Next
slide.
slide
right?
is slide 1 of this first slide deck.
Yeah, first. Oh, is there another slide?
This is duplicate.
So the first item is item.
This one.
No, I think scroll down.
Oh, sweet.
Do we have slides on the, isn't that the L4S operation part?
Maybe it's in
We don't. We can talk about that now. If Greg wants to come to the mic and just give a short talk on L4S, that would be good.
Okay. Don't
Okay, can you hear me?
Yes.
Yes, please go ahead.
Yes, good. All right, yeah, sorry I didn't prepare any slides for the L4S ops topic. There have not been any updates in the draft since last IETF, and only 2 comments have been made on the mailing list related to L4S ops. The first one was about the name of the draft and a suggestion for making the name more specific to the actual content of the draft. Currently, the name is a bit more general than and makes it sound like the draft covers more ground than it actually does. So I think that for the next update, we will look at refining the name of the draft. If anyone has any suggestions on that, I would appreciate that. There's Bob had put a suggestion on the list back in November. Bob Briscoe had, and there was a little bit of discussion back then, but I'll I guess resurrect that discussion and see if anyone has other suggestions for clarifying the name. The other topic was brought up by Michael Belzel in December, and I just responded on the mailing list recently, and that relates to adding some text to L4S ops to recommend that the alternative backoff with ECN ABE be utilized when an L4S congestion controller falls back into classic mode of operation when it detects a classic ECN bottleneck. And I had responded just a few days ago on the list asking opinions from the working group as to whether that was the recommendation the working group wanted to make. Michael obviously suggested it, so that seems to be in favor. Got one other response from Rudiger Guide seeming to support that as well. But I would like to get consensus from the working group, and we could do that either via hum today if the chairs are interested in doing that, or we could take it to the list. We've got a few weeks or 6 weeks left, I think, until the current draft expires. So we just need to get a decision made and text added if that's the path we go down. Any reaction from the chairs on doing a hum?
I can comment as a chair. Full disclosure, I'm also a editor for that document, so I'm not pushing this document one way or the other, but have you got a suggested text for this, Greg? Do you understand how big a change this is? Is this a small change, big change? What's being proposed?
No suggested text, and currently there's actually very little in the document, in the L4S ops document, that talks about fallback to classic behavior, because all of the discussion of that, all the requirements and current recommendations are actually in RFC 9331, recently published. So, you know, ideally, that would be the place to make all of the recommendations, but a little late now. So L4S ops might be the best place at the moment to introduce new recommendations, but it would mean introducing the topic, summarizing the fact that all of the requirements and recommendations, aside from this one we're about to make, live in the RFC 9331, and then make the recommendation.
Okay. I think I'd like to hear if people in the room have any comments to add to Rudiger's and Michael Velzel's comments on list. Does anybody have any comments they'd like to add? Okay, I don't see anyone in the room. I think we could do a hum on this, but I'm not sure that people are ready to hum. So we somehow have to facilitate a hum remotely using email, which is always the most interesting way of gathering consensus. But I suggest what the chairs do is work with you, Greg, and we will send out an email to the list to try and solicit explicit comments on this text. Maybe we can then propose a short description of what the text might be, and we could talk about whether it's good to recommend our own working group experimental draft on this topic as the fallback for L4S. I think that's an interesting and useful discussion. Let's take it to the list and we'll facilitate some sort of feedback on the list to try and get a sense of what people think.
Fine, that sounds good.
Okay. And
Okay,
you
so
are
there's-
next, I believe, anyway, for NQB now.
Looks like the slides are coming up. All right, so this is the NQB PHB draft, currently at draft 17. I'll be presenting on behalf of my co-author, Thomas Fasadi from ARM. Go ahead on to the next slide, please. All right, recent status on this draft. We started a working group last call, as Gory mentioned a few minutes ago, back in November, and that was based on draft 14. A number of comments were submitted shortly after the start of the working group last call, and I produced a draft 15 that addressed many, if not all, of those comments at the time. There were then some further comments, and I guess the working group last call was never formally concluded at the end of last year, so more comments came in through February, and at that point, the last call was ended. I've been working on addressing all of the comments over the last several weeks. I ran up against the draft submissions deadline for this meeting, so I wasn't able to get all of them into draft 16, but and frankly wasn't able to get all of them resolved even for draft 17, which was just posted just a couple of days ago. But that one does, draft 17 does include all of the agreed upon changes as resulting from the working group last call. The current milestone, and I'll go into some more detail on that in the next few slides, but milestone currently was reviewed earlier, is to submit this by September this year as proposed standard RFC. So on to the next slide. Okay, as I mentioned, this draft 17 includes all of the changes that have been agreed upon that came out of working group last call comments. There are a few remaining open topics, and the chair has asked that I add those to an issues tracker so that we can get those to resolution. Currently are 13 issues in the issues tracker using the GitHub issues tracker that is associated with the draft itself. So that should be publicly available. Most, or actually many of these issues are relatively uncontroversial, but either require reorganizing the document a bit, which I have not undertaken yet, or we're requesting some new text be drafted that was more than just edits of existing text. So those are in the issues tracker, as well as a few that are probably require some more discussion. And the next couple of slides, I'll introduce a few of those. So next slide, please. I'm not sure how big the screen is in the room, but that might be an eye chart. That's just a snapshot of the 13 issues in the issues tracker. Not intending to read through all of them live here, but just to document them in the slides. But you can go on to the next one, next slide, sorry, and we'll talk about a few of the issues. All right, one of them is issue number 21 in the issue tracker, and this was brought up in Gore's working group last call comments relating to the upper bound on application data rate for labeling an application's traffic as complying to the non-queue building sender behavior. And the current language there talks about 1% of typical network path capacity as being an upper bound on an application's data rate that could be considered compliant to the NQB sender requirements. And then it goes on to say that today, typical path capacity is approximately 100 megabits per second. That equates to 1 megabit per second as an upper bound today. And the intention is that we don't write this number, don't set the number in stone, but allow it to evolve as network capacities evolve over time, and hence this 1% of typical language. But there's some discussion, I guess, about well, is the 1% too high, or is the 100 megabits per second as a statement of today's network path capacity, is that incorrect in some way? So that's one we need to get resolution on. I think a lot of the applications that we list, give examples of in the draft are well below 1 megabit per second. So I think we can probably change that to a lower number and not be excluding many applications today. Seeing in the chat some comments from Christian suggesting 64 kilobits per second or maybe 256 kilobits per second suggestions. And also seeing a comment that 100 megabits seems too high as a typical path capacity today. I see another comment that yeah, typical is hard to pin down. Networks are very diverse. Yes.
Does any of you guys on the chat want to come to the mic? I mean, Gore is now on the mic. Let's go ahead with Gore.
I guess I managed to get myself at the top of the list. It wasn't meant to be before Christian, but I expect he'll follow up afterwards. I'm speaking personally here without my chair hat for the moment, but I kind of worry about the IETF making statements that 100 megabits per second is normal as some sort of prerequisite for the internet. I'm aware that many people in the world don't have what we regard as normal when we live in a satellite connected place, a place that's really remote. Then this is not a common rate. And I don't think the IETF should be making statements that kind of assume that these people are sub-citizens somehow of our internet. So I think we have to be a bit careful. I'm also wondering whether we really need it that high as 100 megabits for the draft to actually fulfill the goals. So maybe 1% of something smaller might be an interesting topic to look at. And that was my pushback individually, that kind of these numbers seem rather high, where we could do other things, and in future we can evolve the number anyway. So that was where I came from when I made that comment. I'll let others talk now, and let's see how these issues pan out.
Christian?
Yeah, I must say that I'm not enthusiastic about the whole idea of not doing congestion control looks like a recipe for getting into trouble in many scenarios. If you have to pick a threshold, pick it low enough. I mean, I may be biased, but I live in a small island which is connected by a bunch of low capacity link. And it's not uncommon at all here to have uplinks that are in the range of, say, 3 or 5 megabits. And if you take the 1% rule, I mean, it gives you like 30 kilobits.
Mm-hmm.
So I really, I mean, if we do anything like that, anything like saying, hey, some application can dispense with congestion control because they use so little data, the so little shall be really, really, really small.
Okay, that's maybe a point for clarification. This is not to be interpreted as a threshold below which an application does not need to do congestion control. This is just a threshold below which an application can use a particular diff-serve code point. The expectation is that all of the existing IETF guidance and BCPs around UDP, congestion response or circuit breakers, that all still applies.
Jason?
Next one, yes.
Okay, now it's on. Jason Livinggood. A quick comment on the 1% or a number like 100 megabits per second, since you asked for comments there. I think just as a general matter, I always recommend using something like a fraction, a percentage, instead of a fixed number. It gets around having to like index something to inflation, so to speak, because even if you chose 100 megs now, that might look totally ridiculous in 5 or 10 years. So using it as a fraction of whatever the link capacity makes sense. And also to Gori's point, given that link capacities vary dramatically across different access technologies and across time and where people move on a mobile device or whatever, making it percentage based just makes it, relative to whatever that link's attributes happen to be. So I think that's just an easier way of doing it, and then you don't get into this situation of like having to come back later and updating it as technologies, link capacities increase or whatever. Yeah, thanks.
Okay, appreciate that.
Stuart?
We'll definitely. Oh yeah, go ahead.
Oh, do you want to reply first?
Well, no, I was just going to say thanks. We'll keep the 1%. I think that's not controversial. But yeah, it's kind of the question of what do we want to say is typical today, just to provide guidance for applications today. All right, Stuart, go ahead.
I was just going to comment. I agreed with what Christian Wiedemer said about people in different places in the world don't always have 100 megabits per second. I, at my house down by the beach in Santa Cruz, which is in a fairly remote place, I have a DSL line that's 5 megabits down and half a megabit up. So anything that assumes that 1 megabit is too slow to build a queue is going to be sending double my upstream rate and losing 50% of its packets. One of the other things I work on is Thread wireless networking, which is in some ways similar to Bluetooth, except it carries IP packets. And Thread runs at 1/4 megabit per second and realistically about 100 kilobits per second after you take overheads into account. So one of the things that I've always liked about the internet architecture is that it spans such a wide range, from dial-up modems in the 90s to multi-gigabit speeds now. So I share Christian's concern and what other people have said, that what might seem an inconsequential amount of traffic for one network might completely flood another network. Greg and I have talked privately about this. I'm kind of repeating it for the benefit of everybody else. I'm a firm believer that if a flow doesn't want to build a queue, the way it does that is to use L4S and respect the congestion marks to adjust its sending rate to not build a queue. And giving any developers the false impression that they use the non-queue building diff-serve mark, and magically that means their flow now doesn't build a queue. There is no magic. You only avoid building a queue by adjusting your rate. And I'm already hearing developers say, oh, our traffic's non-queue building because we said so. And that's why we don't need congestion control. So regardless of the intent of the document, application developers are treating NQB as a free pass to not implement congestion control, because the network will guarantee they never build a queue, because that's what non-queue building means.
Okay, so I'm hearing that we may need to make the text stronger around the expectation and requirement, really, of implementing congestion response. So this is not a free pass to send, at any rate, and not respond to congestion signals of some kind.
Bob?
You have to join the queue. Can you join the queue? Thank you.
Yeah.
Bob, and please keep your remarks short, because we are running out of time for this one.
Yeah. Just very briefly. Certainly, the draft makes it very clear that you've got to use some form of congestion control, even if it's a circuit breaker, and the circuit breaker would apply to a lot of those cases where we talk about the very low rate link. If there's some sort of application that, like a lot of the applications that are thought of for NQB, which are more fixed rate things that would just drop out if they couldn't have enough capacity for what they're trying to do. So maybe that's where the text can be stronger. And I just wanted to draw attention to the URL I put on the chat. I'm not saying it's correct, but I did a study, but 2021, just pulling available data off the internet, off the web of average bit rate in each country around the world, and I've produced a plot there of bit rate and latency. But the main data that's not there, because I couldn't get it, was the variation of that in each country, which you obviously need for something like this. And if that were available, then we could do something like a percentile, but unfortunately, that sort of thing isn't available.
Louis?
Yes, Louis Chen from Juniper. So I think from the application perspective, if you just say that 1% of the bandwidth may not be useful for anyone, so having a kind of fixed at least 1 megabit and n times of the 1 megabit, something like that, as a specifications, may be easier for software to realize, because very difficult. Some is 64K, one is 100 meg, then what is it? Then you cannot use it for the other application. That's my first comment. The second comment actually is really about wireless. Wireless always changing the bit rate. If you Wi-Fi 2.4 gigahertz, the rate can be changing quite a lot. Then the usefulness of this one becoming kind of a problem in the end clients. So I think you might limit it to some application just within the wire situations rather than the wireless. That's my comment.
Okay. All right. Well, those are helpful comments. Looks like since we're short on time, probably need to move on at this point. The other three issues that I've listed here, I think there's not time today to discuss in the meeting, but there are items I would like input from others in the working group. So please have a look at them. Try to summarize them in the slide here, and just more information in the issues tracker. And let's deal with those on the list. I think that, and the next slide is just wrap up. Next steps are to try to get all of these issues resolved over the next few weeks. I think the mailing list is a good place to have some of the discussion. Also, the GitHub tracker has a nice facility as well for putting comments on the issues. So again, please help get these resolved. And my understanding is that, and I think Gori said this as well at the beginning, that there will be a second working group last call once we've got the document in a state that's ready to do so. So I think that's it for me today.
So thanks, Greg. A couple of things to note with this particular draft is, because we've been through the working group last call and there was a whole range of issues discussed and comments put in, we're going to use an issue tracker now in this stage between the first working group last call and what we hope is the second and final working group last call. So Greg did put up a list of the issues that are in the issue trackers. If you think there's something that's not being addressed in the recent revisions that was raised in the working group last call and now isn't in the issue tracker because it still needs to be solved, please check that out. Please look at that list on the issue tracker, and I expect that Greg will push a thing around the mailing list with a pointer to this saying the same thing. The idea is that we don't go around in circles. We actually now look individually at the issues and take them one by one and see if we can resolve them. So thanks for raising that first one and getting it going. And if you were one of the people who commented and want to check that your comments in, please check the draft and please check the issue tracker. Thanks ever so much, Greg.
All right, thank you.
Hi. Can I start? Yeah. Markus Arment from Deutsche Telekom, giving an overview where we are with our MP-DCCP specification. Remember, MP-DCCP, with that we intend to provide multipath transport to those services which have real-time demand. From that we differentiate to the multipath TCP, which suffers from head-of-line blocking. Next slide, please. So let's have a look first on the maturity state of the multipath DCCP. We, the authors, believe that we made a very, very good progress, and more or less most of the work is done, but that is our view. So let's see what we have accomplished so far. We included all the reviews we received so far. There were some final reviews compared to the last draft version from Simone. We had not included so far. That is done now. They are basically focusing on improving the text around all the multipath options. We have specified, we added a lot of new diagrams, making it more crispy or more better understandable how we intend to use those multipath options. We also added a lot of text on explaining or better explaining our multipath options. So that was basically what Simone raised. We also had a very good exchange with IENA on the IENA consideration section. They reviewed this section, and we came to a final conclusion. So the text in the IENA considerations section seems to be stable now. We also continued together with other parties to use the multipath DCCP Linux reference implementation. And so far, we have not seen any serious issues, or at least no issues which are related to the multipath DCCP draft, which also gives us the confidence that our specification is quite stable. Which is still an open point, but initiated is the discussion around moving from experimental to proposed standard track. That is something which was raised last IETF by the authors. There was quite a good discussion, which gave us the impression that this is possible. I have an extra slide on that, and I will go there more in detail. Next slide, please. Yeah, main changes since last IETF, or since the last version of our draft. As I said, basically most of the issues we solved was related to the review we received from Simone, which improved massively the text around the multipath options. So for those who are not so familiar with multipath DCCP, we think it's now much simpler to read and to understand for what we have specified all the different multipath options like the multipath, prio, and so on. Also, we have two issues related to the IANA review, which is also solved. So far, we don't see anything which needs to be improved in the text, or there's no further review open. Next slide. Also, a short update on our implementation journey. Last IETF, Xiaomi presented their implementation on one of their smartphones, a Redmi K50G phone, and they made a good progress on that. So last time they had implemented the multipath DCCP protocol as such. Now they further enhanced this implementation and they added on top DCCP tunnel service, which is using multipath DCCP. So let me explain the figure here. So on the left, there's a phone now with the multipath DCCP and the DCCP tunnel service implemented. This one connects to a multipath DCCP proxy provided by Deutsche Telekom using the tunnel, which means between the phone and our proxy, there's a DCCP tunnel established making use of multipath DCCP. That's why this tunnel can make use of multiple paths. So the DCCP tunnel is distributed across a cellular path and the Wi-Fi path. We also make use in this framework of the modular scheduling and reordering concept, which is provided by the open source multipath DCCP implementation. And with that, we can provide multipath transfer to any service, to any application running on the phone. That works quite well. What we have presented, what we present here, or what we show in this diagram related to our proxy is the throughput over the 3GPP path and the non-3GPP path, where we demonstrate the seamless handover functionality of multipath DCCP. So here we show that when the Wi-Fi interface goes down, that is the blue traffic, then there is a direct handover to the cellular path without any interruption perceived by the application. In this case, I think you cannot see it, but it's an iPerf screenshot we show on the left. So we used iPerf for demonstrating this, but in general, there's no restriction on the service in use. The proxy itself also provides an interface to the internet. So the Xiaomi phone has access through the MPDCCP proxy to the internet. Next slide, please. Yeah, coming to the last remaining open point, we see that is this discussion around moving the draft from experimental to proposed standard track. I think one of the outcomes of the last IETF discussion was that the area directors suggested some steps or some ideas on how this might be possible. And one of these steps we as authors selected, that was a step, or that is step 4b, which proposed to add some text around concurrent path usage to say in the draft that this should not be used, so that the multipath DCCP is safe to be used, for example, for this handover functionality I've presented in in the previous slide. But if it comes to concurrent path usage, so really splitting the traffic on a per packet basis, that this is not safe to be used. This idea we followed, so we created a new section 3.9. This is not included in the draft yet, but we shared it on the mailing list. This section 3.9 is on path utilization strategies. In subsection 3.9.1, which is not presented here in the slide, but available on the mailing list, we focus on the mobility concept, as I outlined already, and in 3.9.2, that is a critical section where we believe that this helps us now to get your approval to go for a proposed standard, is that we specify, and that is the highlighted text here in bold, that it is not recommended that concurrent path usage over the internet should be implemented. So that is what we believe is close to what the area directors suggested. I think 2 weeks ago, we brought this to the mailing list. The good thing is there was no negative feedback so far. The bad thing is there was no feedback at all so far. And we wonder if we can solve this throughout this session maybe, or maybe after IETF 116 quite soon. There's one question?
Hello, Mia Kulevin from the mic line. This is not a question, it's a comment. So I think we as a community should not put these kind of useless normative language in the draft. I mean, it really doesn't mean anything, right? It's just like kind of doesn't change anything of the protocol, so people will just do it anyway.
Okay, two answers here. The first thing is, with that we followed the suggested text from the area directors. The second thing, for sure we can discuss what it should not means, but at least it gives a clear recommendation to the implementer that it is not a good idea to use it. But for sure it's up to the implementer. If an implementer decides to go for concurrent path usage, then hopefully he knows what he is doing, right?
So I think this is more comment to the group than to you. I know that like this was a discussion that was initiated by Martin Duke, but I think it was initiated by Martin Duke as an individual contributor, not like enforcing his power as area director.
Okay.
But the whole protocol is designed to enable concurrent use, right? So that's why I find it like kind of specifically useless to put a normative language in there to like say you shouldn't do it, right? This is how we designed it, but you shouldn't use it. But this is just a high level comment.
Okay, thank you. I think there are more people in the queue.
So I'm going to give an individual comment as well on the should not be implemented. I think the IETF can't tell you what is implemented. They can tell you what they think the internet is safe to do, what the protocol spec should be allowed to do. But I get the idea. I get the idea of declaring out of scope concurrence use of congestion control, because we have work items in the future that probably will anticipate this, and this surely, if it's not finished as a work item, can't appear in a PS as a piece of work. So I think the words probably need a little bit more from my perspective, and I don't like the second sentence that comes afterwards, which kind of says, and by the way, if you don't like the should, then here's the way to do it anyway, which to me makes the spec look experimental. As in, we're still experimenting. So I've got some feedback personally, and obviously I'll put my chair hat on at the end, but I'd love to hear other people's comments as we go through the mic line.
I think I'm next. So thank you for putting this in. I might have phrased this a little bit differently, but I don't think we need to argue about the words up here. But what you're getting at is, I think, what we need to get at, which is that, what does experimental mean? Experimental means that we don't really, as a community, know that it's safe to use, or is beneficial to use for like general purpose applications. And I think that's where we are with concurrent multipath as a community in terms of scheduling and so on. Like, you kind of got to know what you're doing. So if people disagree with that statement, then that's a discussion to have. If people want to word this differently, I'm fine with that. But of course, this same thing is going on in MP Quick. I'm not the responsible AD for MP Quick, but also, frankly, there's going to be a lot more implementations of MP Quick. So I think we can look at this a bunch of different ways. But I agree that people are going to do what they're going to do, and people who, quote unquote, know what they are doing are going to do it. But I think somebody who's reading this naively should not think that these problems are solved. And that's what I'm hoping to get across here. So thank you for doing this, Marcus.
Thanks, Martin.
Go ahead. Yeah, so can you go to your experimental result slide? The result, experimental result.
You mean this one?
Yes, yes. So what is the meaning of that color shaded on the right side? Are you sending that packets in the concurrent path, or is it just one path at a time?
In this scenario, it's one path at a time. It's not concurrent.
Okay, so the first one, the color is through non-3GPP path.
Yes.
And then the next color
Yes,
is a 3GPP
exactly.
path.
Yes.
Okay. Okay. So when each case is you have only one available path. Am I correct?
In this particular scenario we present here, yes. Nevertheless, the open source implementation we use is also able to provide scheduling on a per packet basis, so to aggregate throughputs, but that is not what we present here.
Okay, thank you.
Just to get a sense, who has read the document, please raise your hand now. Oh, it's like five people?
In the audience, yes.
Okay. So I would like to do a hum now, if you agree that this document should be changed from experimental to standards track, then please hum now if you're in the room, and we'll use the online tool for people who are remote later. So please hum now.
You want to ask the opposite as well?
Yeah, and if you believe that that the track should not be changed, please hum now. Okay, that was a lot louder than the first one.
Let's try the online as well.
Yeah. Do I need to do anything more?
Just say it.
Okay, this is now for the people who are remote. Please raise your hand, or don't raise your hand.
Okay. You don't see the IUDs video.
Okay, that pretty much matches the hum in the room.
You want to just say the numbers for the room?
Yeah, so eight people raised their hand for changing the track, and 12 people did not raise their hand.
I wonder those people who are against moving the document from experimental to proposed standard, if they really read what we shared on the mailing list, because so far this is not part of the document. It's only on the mailing list available. That is only an excerpt I share here on the slide. So the full text is on the mailing list. And I would be very happy to get your feedback, especially from those people who are against moving into proposed standard, to get this feedback on the mailing list, to really have a good discussion on that. Because at the moment, for sure, I perceive the feedback, but I don't have any idea why you are against.
Do you have more slides?
One more.
So just stepping in as a chair for a second here. I think Martin's question about why it should be PS or why it should be XP is exactly the conversation we're trying to facilitate from this discussion today. So please don't take the hum or even the poll as actually an indication of the working group's opinion. Take it as the fact that there is a divergence of opinion. There are definitely some people who said they were against. There are definitely some people who said they were for. So please continue to discuss this on the list, and we will have to find a decision to this question. Just to confirm that that's the position.
Last slide. Okay. Thanks so far for all the comments, and that brings me now to the summary. Yeah, final step we see is that we have to find a conclusion on this question, whether to go for proposed standard or keep the experimental track. And yeah, you are welcome to discuss this with us on the mailing list, as outlined already. And yeah, that brings me to the final questions I have to you, to the community, but also to the chairs. At least my feeling is that we get not this question today resolved if proposed standard is the right track. So I understood we have to continue the discussion here. And my impression is also, that brings me to the last bullet point, that this is something which needs to be resolved before we go for a working group last call. So that is a question maybe to Gori.
Well, the big thing to sort before a working group last call is what the document status will be. The level of review and scrutiny will depend upon that proposed document state. So let's try and work out that document state as best we can to get a good consensus behind any decision to go for PS. And then let's find committed reviewers who are willing to review the document in detail, preferably including people from the MP Quick community, to make sure we are consistent across our standards. The latter part we can give over to the chairs. The former part has to be done by the editorial team to motivate the change to a PS. So great talk, and please try and get an answer to this from the list.
Okay, thank you.
Okay, so this slide deck is my slide deck. Yeah, sorry. I'd like to wear an editor's hat on behalf of Joe and also on behalf of DPLPMTUD. I'm going to summarize in these slides feedback from Joe on the working group last call outcome. So next slide, please. The working group last call was held in January for progression as proposed standard. I didn't see feedback in the working group last call on this about not being proposed standard. I saw a little discussion, didn't see any strong opinion on the proposed standard status. The Document completed the working group last call, but it had comments and was returned for the working group for revision. Two sets of comments were requested specifically about the maturity of the spec, and these were expert reviews by Magnus and Colin. And other comments were followed up with discussion on the list, and we have an int-area early review. So thanks to all who participated in that working group last call. Next slide. Joe identified 3 basic issues which he thinks will take more work to address than simple editorial work. The first one was the use of the DOS option in fragmentation, which he's now renamed to not be DOS because it had nothing to do with denial of service, and that was just a bad use. It's now called RDOS. And Joe prefers to leave this RDOS option to place the options up front, like true fragmentation. Mike Hurd called for a rollback on that. I don't know if there's going to be feedback during the IETF on that. Please come to the mic if you have a comment on any of these issues. Joe also had a challenge against whether the encryption was at the same maturity as the rest of the document. And since this document's been progressing for a while, we want to try and get this out of the working group. So if encryption needs more work, Magnus said, should it be a separate spec? Is it a separate level of maturity even? So there was discussions around encryption, and Joe's proposal was to avoid stating the encryption algorithm details in the draft and simply reserve the code point for encryption rather than assigning it. Authentication was the other topic which raised more eyebrows than the rest of the document. It's arguably very close to TCP/AO in the method, and we could do the same, reserve the code point rather than assign it. But Joe thinks that there's a lot from TCP/AO which can be reused. So how should we play out with these encryption authentications? Should we start a separate ID on them? Or should we not? I think the working group has to decide on these things after this meeting, but I'd like feedback from people if people have any comments. Magnus, do you want to relay your comments directly into the mic as well? Okay, fine. Let's carry on. Next slide.
Sorry.
Oh, yes, Mike. Sorry,
yes,
you're also doing a comment on chat and something else. Okay, carry ahead.
Yes. So, Magnus Westland. On this, I really don't understand Joe's hesitance to just put this outside, etc. It seems to be the cleanest way of dealing with it. Because it's incomplete specification. It's very hard to understand currently, I think, about where are all of the pieces, etc. And if you can't put it together now in a timeless fashion, it really stops the rest of the publication. So I think there's an unnecessary delay for the whole thing.
Okay, point taken. Mira?
Yeah, effectively, I just want to agree with Magnus. I think we should publish this document as soon as possible. And if that means we should take this out because that needs more discussion, then that seems to be a good solution. The only thing I'm wondering out if there's still enough energy to actually start a new document here, because I think we still need that.
We did offer the chance to work on the encryption technology as part of this work item, so we can look at whether a separate document is a good way forward. And of course, there would have to be energy. Maybe we would get more energy and more review on a separate document than on the complete document. Not as the presenter of this, but as the chair, changing my hat to chair hat. Let's go to the next steps, and I will talk about the fact that we didn't get that much security review for this document yet. And I think getting good security review is going to be important for the security methods in particular. And that might be another motivation for why we put that as a separate document. The key point here is, from Joe and also from the Shepherd's point of view in progressing this, is that I think there is now energy here to see this document published. So I would love to see progress here. Joe's already started the first of these revisions. I think we will see more, especially if people help and support this. Let's see if we can get something through to publication and request a final working group last call. So let's try and find a way through these different issues. And that includes the security part. Any questions to Joe that we would like to relay to him? He will watch the proceedings afterwards, even though he's not online at the moment. Any more comments on this document? Then I think we'll go for the second of the documents we put through working group last call. Here I'm no longer pretending to be Joe Touch. Instead, I pretend to be Tom Jones, who's the co-author of the Datagram PLP MTUD draft. Next slide. We wrote this document to provide PathMTU discovery for UDP options, and it can be used in multiple ways. And one of the things that came out in the working group last call is to try and identify the different ways in which you could use the method in combination with UDP options. Next slide. The call was for proposed standard. We completed the working group last call. It's now being returned to the working group, primarily because it needs to be published at the same time as the base spec. We think that a new revision of this document matches the review comments and follow-up from Magnus, and also the comments and follow-up from Med, Joe, and Mike, and a few other people off list. So thank you everybody who contributed to this. And I think it also addresses the interior early review, but we haven't had confirmation of that, so we'll check that after the working group meeting today. Next slide. We added various things in the revisions, particularly a figure, but also discussion of different styles of responder design, largely through comments in the working group last call. And we added a change to the recommendation for transports that perform DPLP MTUD over UDP options to use encrypted padding as encrypted transport should. Next slide. Next step is to resolve the final issue from Med, resolve any future issues, including confirming the interior review has been addressed, and then await completion of UDP options. And finally, to request a working group last call. Any questions on this talk, please? Is there anything in the room?
Doesn't seem to be any comments.
Excellent.
But you've
Okay,
done a
so,
good job with the acronym, so perfect.
Yep. Please follow this up on the list. You'll notice a number of other drafts mentioning UDP options in today's meeting. So please help us finish this work. That would be good. End of slides.
Hello, can you hear me?
Yes, we can.
Okay, so this is an update of the work on the careful convergence for congestion control. So my name is Nicolas Kuhn, and this is content work with Emile, Gori, and Christian. So next slide, please. We have just a slide on the problem we are working on and trying to sum up a little bit the history of the document. Basically, I'm working in the geo satellite or but also LEO, but this is focusing on the geo satellite problems where we have a very high BTP and sometimes having a quick ramp up to get up to speed can really help. Um, if you look at the right on the slide here, we just not the target picture. The blue line, we are using a very performing TCP enhancement proxy where we have an almost instant ramp up to the various speed, while end-to-end without TCP proxying methods have issues in actually finding the adequate rate. So we think that storing lots of statistics is something that is done in lots of different congestion control, and it's something that is not done in quick, and we think it's very interesting to see to what extent it is relevant to use the information from previous session to actually initialize new connection. And but most of all, the topic here is how you are careful to avoid any problem that you may have found. So next slide, please. Basically, we had developed the concept in a quick working group with the TPP draft. Then we have defined different states that I will show up later on what are the different steps for the careful resume. And since the feedbacks we had in the last IETF, we moved these documents to the TSVWG working group with a major rewrite of the spec and mostly worked on by Gori, so thank you. And it was mostly focusing on refactoring all the content that was within the document. And now we have two documents. So this is a careful resume document focusing on how you carefully resume a session. And we have a BDP frame document for how you can implement that in quick and different trade-off. So next slide, please. Basically, these documents' objectives are to address the careful convergence of congestion control, be cautious and provide the methods to be cautious, try to see how we can reuse the set of computed congestion control parameters. And we have started a huge list of the different requirements on what it means to be careful and when you can move to the next step in the different phases. So basically, one of the main important part that we have to focus here is that sometimes some things that you have learned in previous session may not be valid anymore. So you have to be very careful on how you resume the previous parameters without having checked them beforehand. So next slide, please. The core part of the phases is shown here in this slide. So basically, you have a previous session where you observe the network. And then when you want to resume a session, first, the client may have a word on it. So it may be okay or not on resuming the session or not. And you may also have some timer information saying, the information that was told from previous session is valid for a certain amount of time. Then if all these conditions are met, saying the client is okay and the timer is valid, then you move to the reconnaissance phase, where basically the main part here, the main objective here is to check the consistency of the previous session information. What do we mean by that is if the information is consistent, mainly the minimum RTT. If the minimum RTT is to some extent the same value as the one you had in the previous session, and also if you have received a whole initial congestion window, you can move to the next step. Otherwise, if the RTTs change in a significant manner, or if you have lost any packets in the initial condition window, then you resume to a normal session, normal condition control. Then if you are in the unvalidated phase, the main objective here is to have a fast but not instantaneous convergence towards what was measured as a previous rate of the session. And one main important part here is that if you encounter any sort of congestion, for example, you lose packets or you see a significant change in RTT, then you have to go through a retreat phase where you just stop using previously measured parameters and you reinitialize all the condition parameters to try to drain any qubits built at the bottleneck during the unvalidated phase. So we have some figures on standard congestion control to see what it means. So next slide, please. So this is a normal slow start in quotes because what is normal, but so basically you have the initial congestion window, an exponential slow start, and then a congestion avoidance phase. In larger BDP scenarios, this can take a lot of time to reach what was the what is the available rate. So next slide, please. What we did in the first implementation of the zero BDB frame is just not being any cautious at all, and we know that we think people could be tempted to do the following. So let's say you measure the previous rate and you just use it directly, and then resume a slow start. This is something that people could be tempted to do, and that is why we need that discussion needs to be done and on the recommendation, and there could be recommendations on how you resume a session to avoid this kind of scenarios. Next slide, please. So what we propose is you have the reconnaissance phase where you send the initial congestion window. Then you have something unvalidated phase that is not instantaneous but very fast, and then you resume a typical exponential slow start. So this is supposed to be faster than the method using standard slow start mechanism. Next slide, please. The thing is, if you have any loss of packets in the unvalidated phase, you just retreat to what was normal. Next slide, please. So there are some discussions that we need to have on what is validated and how we validate the saved information. Because basically the server must check. One important part of the document and the rationale behind it is that the server must check the validity of the received value and that they are still valid because the path might have changed or the capacity might have changed as well. Next slide, please. This is just a slide to explain what is the companion draft of this. So basically, the previous draft discusses guidelines on how to carefully resume sessions, and this draft is how we implemented it in Quick with 3 different variants. So next slide, please. If you look at the bottom of the slide, we have different approaches. So local storage, new token, BDB frame. So these approaches are discussed and in the document, and there are inherent advantages and drawbacks as well. So local storage is that the previous parameters are just stored at the server and only the servers knows about it. In the new token version, basically the previous session parameters are included in an encrypted blob that is sent to the client. The client cannot read it and resend it to the server. And the BDB frame is that the previous session parameters are sent to the client and the client can read them. So the draft focuses on how the BDB frame is implemented in Quick. We have also integrated a method for the server to guarantee the integrity of the BDBP information value returned by the receiver to the server. Next slide, please. I think that's the last one. Yes, so we presented the careful resume in the previous IETF. There seemed to be some appetite for working on this in the TSVWG group. So my main question is this still the case? And if the working group will consider adoption of this draft or not.
Ingemar?
I hope that you hear me.
Yes.
Yeah,
Yes.
obviously. And I guess I believe it in general. I think it's interesting work. But what perhaps can be one of the pain points here is cases where you have shared last mile access, like for instance, fixed wireless access or fiber connection, where you have many tenants that might share the link. It could be it can change depending on the time of day and things like that. How many actual users uploaded the link is, and that's a problem. Perhaps something that needs to be experimented with and see how it works. So, but in general, I really think it's interesting.
Thank you. Indeed, yes, we have focusing on the satellite scenarios for which we had done some wild experiments to see the performance we had, implemented some of the safety check. There are some plans to further work on it, and indeed the question would be to what extent being too rational by reusing, too careful by reusing previous session parameters, you can actually do something that is not as good as a standard slow start. And also the behavior would be different from BBR and cubic. So there is, we need indeed experimental data on this. Yes, I agree. For other scenarios that we had, the one we had experimented on.
Thanks.
I think I'm next. Thanks for the draft. This is an interesting idea, and I did take a quick read of it earlier today. I think this draft as it is, I know you've received a lot of instruction from the quick working group and so on, and I hope I'm not gonna like do the opposite of what the guidance you've already received. But I think this draft is a little bit weirdly positioned. And maybe this is because it was split off from the BDP frame stuff, but it seems to be about quick, but it's not like a companion to 9040 in that it does not, it does not really get into the weeds of like how you cache the congestional parameters which are listed in 9002. Instead, it's this general, like this protocol agnostic, frankly, algorithm on how you can sensibly approach this congestion controls caching issue. And I wonder if this would be better as especially in this working group or in not Congress, should that come together finally. If this is better positioned as that, as generalized protocol agnostic advice for this kind of problem. Thanks.
I'm not sure if I assess all the Congress discussion. I think this discussion, we realized when we submitted it that we still have quick in the title. The thing is, it was done with quick transport protocol in mind, but I think it is more a congestion control aspect that congestion protocol aspect. It's more of a congestion control rather than a protocol that you use. It is independent of the protocol that is using.
Yeah, that was my impression as well. So maybe my suggestion is just especially since you're in this work group now, just cut quick out of it entirely and just have this be advice for all protocols. I think it applies to TCP as well as, of course, the SCDP, etc. Thanks.
Thank you.
Randall is next.
Hi. So I definitely find this interesting. I played around with similar concepts about, 15 years ago or more. And I definitely think it can be useful to get to steady state quicker when things work out. One thing I would one minor point I'd point out is when you had listed the things that could be changed when you resume. The other big thing is the cross traffic and competing traffic can change, not just the link and the path and so forth. The traffic change is actually one of the big things you're going to have to be concerned about. The other thing I would point out is you have a fixed delay, it appears, without having actually read the draft, after which you just throw it away and just do normal congestion ramp up. I would mention that what goes on is, over time, your information about the state of the connection grows increasingly hazy, uncertain, and this is directly related to the time that has occurred since you made your measurements. I would suggest that you take that into account in your algorithm, perhaps by reducing the amount you jump the bandwidth by as your estimate becomes more and more uncertain, as opposed to just simply cutting it off after a certain number of seconds or minutes or hours or whatever. I think that might play better. The last thing I'm going to suggest is that one of the things you're going to need to do is measure the impact of this on existing flows when a new flow of this type comes into the mix, and what happens to fairness and the throughput of other things that are on the links in different situations. Situations where it's not fully utilized, situations where it is fully utilized, etc. Just make sure you're not causing the other congestion things to get whapped by the result, or whether or not it just improves the stability, all the flows getting to a stable state quicker, which is what the goal here is. So that's it.
Thank you very much for the traffic change. I think this is the fact that you have more traffic. I think we have mentioned it in this document, but we'll further check that and make sure that we actually cover it in the document. I think the reducing the maximum available the value that you had registered, and reducing that the function of the age of the ticket is a good idea. I think we need to take that into account as a potential solution for the how to be careful with time, and for the impact of the that you have on existing traffic. So I just sent an email to the list of some experiments we did. Surprisingly, we did the experiment we had. We were very safe, and we were causing less harm than a standard slow start. But this is something that also, as was said earlier, that we need more experimentation on. But this is indeed something that we need to carefully point in document, the impact of the fairness on the other document flows. This is something that I'm not sure we have listed. So.
Sounds good.
Thank you.
First of all, I hope my mic level is okay. This is my first time speaking to Meet Echo.
Yes.
I'm really glad that this work is happening. The restart behavior TCP has bothered me literally for decades. But I want to relate a story which I think contains a lesson which is really important. A couple of years ago, Keith Weinstein presented REMI TCP, which was an ML-based congestion control, which sets a whole lot of people's hair on end for a bunch of legitimate reasons. But he got profoundly better results than standard congestion control in a whole bunch of things. And that kind of bothered me because standard congestion control in a lot of environments is pretty close to optimal. And it's like, you can't do twice somebody who's doing 90% of optimal. So there's something fishy going on here. Well, I went and looked at his paper, and all of his workloads are transactional workloads. And what the ML tool does is a better job of estimating how to restart connections than the default explicit algorithms in congestion control. And this subproblem is one problem in TCP congestion control where ML is absolutely the right kind of answer, because the right answer depends on what the workload is of the other traffic on your network. And you want to adapt how you restart to what happened to past restarts in your traffic load. And there's a huge opportunity here, a huge research opportunity here. The standardization piece is actually the framework. And there has to be some sort of piece of it that's ML, which is crafted outside of the framework. But I'm excited. So it's cool work.
Thank you. And yes, on the side, we have been working on a PhD on that on the using ML for detecting a rising congestion in the network. I will send the papers to the list, but this was not focusing on the restart indeed. But thank you very much.
Yeah, it's specifically the kind of question that some sort of learning has got to be the right answer.
Thank you very much.
Question?
Yeah, I mean, I have been working with this team for some time, and I think that we do have, as I say, we do have a problem with restart. This particular team is focused on scenarios that involve long delay links, and you have an even worse issue if you are going to do communication not just with through a sat or geosat, but to the moon or to Mars or something like that. I mean, if you consider to Mars a delay of 20 minutes each way, whether you have 2, 3, 5, or 7 round trips to start up the connection does matter a whole lot. So, well, this is an important issue. The point that Nicolas made is interesting. I mean, the point there is that if we do not get some guidance out on how to do that reasonably, what will happen is that eager folks will just restart with the previous value of the parameters. That's what will happen. It's not that they will restart by doing extra careful. No, they have a lot of application pressure to restart quickly. So the trick there is how to teach them to be somewhat careful so they don't break everything, yet get the benefits. And I caution about the being too careful part there.
It is easier when you implement this to just jump to the previous connection rate. So the thing is also it is much complicated to implement this kind of mechanisms, and you lose what you could see as your own flow preferences. But sometimes you lose. But it is much complicated to implement these recommendations than not implementing it. But the problem then that we always face is when we had internal discussions on the retreat phase, some people said to us, but when you retreat, why don't you just have the congestion window? We are being too careful when we see that something has changed in the network, and we just want to be much more cautious that that is needed or not. I think this is something we need to discuss on, to agree on what is being too cautious and what is actually still having a slow start that is efficient. Even if you're when you notice changes in the network, you may want to do as good as a standard slow start. So this is something we need to discuss.
I mean, the other thing you don't want to do when you have a very long delay link and a large BDP is lose a whole BDP worth of packet that you have to painfully retransmit later. Yeah. So, I mean, I think, Nicolas, in your presentation, I'm sorry, I should have told you that before, but in your presentation, it'd be better to consider something a bit more modern, like at least using the iStart mechanism that try to exit on detecting signs of congestion rather than waiting for the actual crash and loss of packets. That's also something we should consider. But well, I look
Yes,
forward
indeed.
to working on that. And to Matt's point, it's something that definitely should be addressed in Congress. And because it goes with other ideas, like Matt mentioned machine learning, but there is also things like using shopping as a way to quickly estimate the bandwidth, which has many of the same properties. So yeah, let's work on it.
Yeah, closely following this work. And I think there's a couple areas we've had some internal discussion. We need to move the list. I'm intrigued by the problem of which we talked about outside the group, how careful to be under certain circumstances. And the other thing is I would like to see a document go into some discussion about, what kind of checks, as was mentioned by previous speakers, what kind of checks do we need to do to be safe, and how can we help them out? I definitely think this work is important and would be great to see it picked up.
Thanks.
Randall?
The only additional comment would be, since this is going to be basically a protocol agnostic algorithm, when you talk about what is congestion in order to, when you're going to fall out of it, I think you need to think about how you're going to define that. Not, as mentioned, not just loss, but it could be, depending on the congestion control algorithm that this is being applied to, it could be just simply an increase in delay, such that you can react more quickly to see if congestion is starting to build. So much like some of the real-time congestion control algorithms. The point is, when you write it somewhat agnostically, such that the algorithm can use what tools are available to it.
Yeah, thank you. That's a really tricky part, because we had issues in when Christian worked on it at some point on the specificities for the GeoSatcom scenarios when you're using BBR or cubic is very different. So, yes, it's very hard to be a congestion control agnostic. Yes, we'll try to work on it.
Christian, the queue is closed. Could you write it in the chat what you wanted to say? I'd like to do a quick show of hands who has read the draft. And if you're remote, please put it in the chat. So that's about 5 people in the room. And a few in the chat. No, still coming in. At least 5 in the chat as well.
I wonder if say a word about positioning this work in the IETF. It comes as no surprise as TSVWG chair that we talked about where this work should be done if we do it. And there are various places this work could be done. If it's just a modification to Quick, it could be done within Quick. It's probably better not done within Quick, because it probably is more than Quick, although Quick is the obvious place where you could do this first. Then should it be done in a separate working group? Should we form a working group to congestion control? Well, clearly, while that was even being debated, the idea to form a congestion control working group is maturing, and the idea of Congress will be talked about in the next presentation. The whole idea of congestion control is now becoming something which is a hot topic. Excellent, I love this. But where should this work be taken? Now, we talked to our ADs, and I don't particularly like channeling the AD, but maybe on this one I can try. I think this particular piece of work could be positioned by the IETF in TSVWG as a work item on congestion control if it applies to more than one protocol. It would need to be coexistent with the work in Congress. It would need to not violate the BCP which is being developed there, but I suspect that can be done through coordination. And there could be merits in taking this work in TSVWG rather than in a work item that has to follow a Congress and BCP document. So I think this is a topic that we should actually talk about in this working group today. And of course, once you mention channeling your AD, you get him in the queue behind you to say what he really thinks. So Martin, now go ahead, please.
Hi, yes, I mean, obviously, the congestion is hot off the presses. It's going to be called the Congestion Control Working Group, unless the ISG hates that too. So that's obviously looming over all of this. I don't believe in holding up documents to wait for this administrivia stuff to happen. So I believe, so I mean, pursuant to my earlier comment, I think this is best positioned as a generic protocol agnostic document. And if the authors want to go in that direction, I would encourage us to, have all hats off. I would like to adopt it. AD hat on, the proper place to adopt it would be in TSVWG today. And if and when the Congestion Working Group is chartered, then we can have a discussion about where it really lives. I suspect that there's enough bandwidth. Well, it's up to the working group chairs and the community there if they think they have enough bandwidth to do this simultaneously with 5033 BIS. And of course, this working group has something to say about it as well. But we're talking about a lot of the same people.
Yeah, so we'll do a hum if we want to adopt this document. And I'll start, for the remote people, I'll start the Meet Echo tool. So the question is, should the working group adopt this document? If you think so, then please hum now. Silence. If you don't think the working group should adopt this document, then please hum now. Also silence. Okay, but it looks like the remote participants are more willing to give their opinion. We have 20 people who want to adopt this document. Oh, increasing. And only one person who thinks we should not adopt this document. Does this one person want to speak up and tell us why we should not adopt this document? Apparently not. Okay, I'll end the session now. So we have 30 people participated. 1 thinks we should not adopt this document, and 29 think we should. As always, we'll confirm this on the list.
Thank you.
Thanks. I think we can move forward with the next item on our agenda, which is Mark Mathis.
Nope.
Good morning or good evening. Waiting for the slide to load. First of all, I have a little announcement. I unexpectedly retired from Google in January. And so I am pivoting to freelance. And one of the first things I did is I'm going to get back in with some of my old favorite haunts and start doing some research that I would rather have been doing in some ways. So next slide. This draft only started after I retired. And so it's very, very early work. My goal has always been to find ways of characterizing congestion control that gives you a good definitive understanding of what things are healthy and what things people shouldn't do, which is not based on comparisons between algorithms or anything like that. Because I'm essentially using the draft like a little wiki, I'm going to keep it terse and to the point. Experts will be able to understand it, and a lot of other people will say, what does this mean? It's really for the people in this room and in Congress if and when it appears. I can foresee many different routes for this document. One of the issues with it is it's really a bunch of little separate papers, each of which is a separate discussion about a separate criteria, and individual pieces of it could be picked out into other documents. And I can imagine that done. Next slide, please. So I'd like some help. In particular, I want to know if I've overlooked silly things that congestion controls can do to each other that I didn't think of. The other thing I'm really worried about is I've basically been away from the IETF for more than 10 years. And it's pretty easy to discover prior art in the form of RFCs that were adopted and papers that people have published. What I don't have is a good sense of things that have come into the IETF and been heavily debated and then rejected. And the problem is I'm likely to propose something that's previously been slaughtered. And I would, please be gentle. Please let me know. And then the other question is, which we just heard a fragment of, and I suspect the same answer sort of applies. Where should this work proceed? Next slide. So one of the things that I rely on very heavily is a sort of a slang I decided to create, under adverse conditions, which basically means it's a linguistic shorthand, which means any way you make the network worse, the protocol, the congestion control has to have a monotonic behavior relative to what it was over the entire span of all the characteristics, possible characteristics of the network. I realize I left off ECN marks on the slide. That was just because I was typing it in a hurry. But the point is you want to ask things about whether or not the behavior is monotonic relative to certain reductions in the capabilities of the network, of increased cross traffic or whatever. Next slide. So I'm only going to talk in detail about 4 of the 13 criteria in the paper. Next slide. Freedom from congestive collapse. This is pretty well understood in this working group. The internet melted down a little bit before my time. I was not doing internet stuff in 86 and 87. But Van Jacobson fixed the internet by addressing some severe issues having to do with congestion collapse. And as a community, we're pretty sensitive about noticing, even from thought experiments, whether or not protocols are prone to congestion collapse. And there's certainly some ways of testing things. Next slide. However, the application developers, and I've had some outright arguments with some people at my former employer, seem to think that TCP can fix all silly things that applications can do. And I am very keenly aware of some cases where there are some applications which, when you deploy them at scale, at a big enough scale, can cause congestion collapse and have done so, much to the detriment of the other users. We need to actually address this issue. And one of the issues about this document is a couple of the criteria, in particular this one, has to be applied to the entire stack. It's not just a transport issue. It's an application issue. It's a library issue. And that will have some interesting conversations in other meetings. Next slide. The most common case that you see in user applications is applications that do fairly large network transfers. And if something goes wrong, they start over from the beginning. The worst case pathological case that I've ever heard of was a major software install, which in the Southern Hemisphere ran out of time before it finished and then restarted again the next night until it finally finished. And who knows how much network capacity that burned before it was fixed. This kind of fix, for many kinds of applications, this is pretty easy to fix. You just need to be able to not start. You need to start from the data that was previously delivered. However, this doesn't technically fix the problem in a formal sense because the signaling has to be repeated multiple times. And so you can't write the document in a way that's too rigid, because in fact, under adverse conditions, even if you restart from where you left off, there's a little bit of data that gets set multiple times, and it does cause there technically to be an increase in overhead under adverse conditions. Next slide. So one of the things I did in the document is borrowed some language from US court system. It's actually not so much used in laws, but in the court proceedings, the term material versus non-material. A material violation means that the violation was important to the outcome of the event, the outcome of the experiment, the outcome of the law, getting the ticket. The non-material violations means, well, you technically violated the rules, but it doesn't really matter. It's not important. It's a side issue here. And this, I don't know if other languages or other countries have similar concepts, but this is something that I ended up using, but it precludes the use of the word must. And what the document actually says essentially is a shorthand for you should always say should, and you must document exceptions. And there sort of implicitly needs to be some description and justification of the exceptions are okay. Next slide.
Matt, just to let you know, we have 3 minutes left.
Ooh, wow, okay. Freedom from regenerative congestion. This means that applications, primarily applications, must not push harder if they're not making the progress that they want. Next slide. Was I supposed to have 15 minutes? Anyhow, upper bound on steady state loss. The issue here is that transport protocols, by and large, modern SAC-based protocols can operate at very, very high loss rates. But DNS and SYN exchanges and other single packet exchanges are often very fragile. And actually the criteria for transport being safe is that they not harm these single packet transaction protocols. And the current document says 2%. I wish I could say 0.1%. Cubic and Reno have no hope of passing 2%. And teasing apart, finding a compromise answer, a well thought out answer to this question is critical. Freedom from starvation. Next slide, I'm sorry. I actually think that, next slide. Hello. Freedom from starvation. I actually think that this property is more important than anything that resembles fairness. I think it's more important than being efficient, meaning being able to fill the network, that you want to guarantee that a small number of flows can't lock out other flows. One of the points about this is Reno and Cubic egregiously fail this criteria. And it will be interesting to see how that plays out in the long run. Let's see. I'm going to skip two more slides, go to looking forward. It's my last slide. So this is where I am. I'd like to solicit some help. I'd like some advice as to where I should place this next. I see a bunch of next steps that could be done. And actually something I didn't mention at all is that different criteria in the draft could have different maturity levels. Different pieces could be spun out in different states. So queue closed, I saw. Hello?
Okay, thank you, Matt. Sorry for cutting you short. We were running out of time a little bit here. But I think we have to take all the discussion to the list.
Okay. Thank you.
Yeah, so we're basically at the end of the agenda, even so we had scheduled 2 more talks originally. So if the speakers for those talks just want to come to the mic and give like a very, very brief heads up at the mic, that would be an opportunity now. Otherwise, we would try to squeeze it in on the Thursday session, but we can't promise. So like, go ahead. Sorry. You can just use that mic as well. And you have to be brief because we're already at the end, right?
Understand. So this is just an introduction to the media header extensions for wireless networks. What we're proposing is that wireless networks experience very high changes in bandwidth due to interference and other conditions. And the proposal is, and when dealing with media headers or media, a lot of there's a lot of drop rates and other things that we have to handle. What we're proposing is a few extensions to allow the wireless network to look at those extensions and do the shaping accordingly. This has already been proposed in 3GPP, and it's handled for RTP since those headers are visible. What we're proposing is a limited set of things that is catered specifically towards the transport and enables the network to do the QoS properly, so that there is no rebuffering and things like that. So that's the whole proposal in brief.
Perfect, thank you. Please read the draft and comment on the list.
Hello, this is about the encrypted transport protocol path explicit signals. It's about sending explicit signals from the endpoint to the network and from the network to the endpoint. The proposal is to have these metadata to be encrypted in a way that only authenticated on-path network elements can encrypt and decrypt it, but it's only for processing, not for adding or deleting these metadata. This is in line with the design principles that are being discussed in the IAB for the need for explicit signals, with most of the transport protocols moving to the encrypted mode, that monitoring any of these metadata which was previously possible is no longer possible. So the idea is to provide only the required metadata in a way that a network could efficiently use it for network management and performance optimization.
Okay, thank you, everyone. That concludes our session for today. Thanks again to the note takers, and we'll meet again on Thursday afternoon.
So how to prevent the queue from going to long? This is very transient. So yes, this proposal But this is